Welcome to PCA Career Point. So now we are going to discussing about the principal component analysis, numerical or solved example. So this is important in our machine learning subject. So principal component analysis, actually it is the concept of dimensionality reduction technique. So let us go how to solve this principal component analysis. So apply PCA for the given data and reduce dimension from 2 to 1. So two dimensions are given, we have to reduce it to 1. So first of all, the PCA algorithm, so the here steps are written as per the PCA algorithm. So first of all, we need to calculate the mean of the given data. So x1 is 4 samples are given 4, 8, 13, 7, x2 11, 4, 5, 14. So x1 mean is 4 plus 8 plus 13 by 7 by 4, it is around 8, and x2 mean is 8.5. So second step is we have to calculate the covariance matrix. So for the first covariance matrix is covariance of xx and covariance of xy, yx and yy. So here the notation is given x1 and x2, so that's why covariance of x1 x1 for that formula is 1 by n minus 1 summation of k equal to 1 to n xi minus x bar whole square. It is mean. So because x value is x1 comma x1 and x1. So for this covariance matrix is both are same, so that's why. So we'll use only xi minus x bar, otherwise we have to write xi minus x mean into yi minus y mean. So for this case we have to take two values are same, so that's why xi minus x bar into xi minus x bar. So 4 minus 8, 4 is nothing but x value, 4 minus 8, 8 is nothing but a x1 mean. So 4 minus 8 whole square plus 8 minus 8 whole square plus 13 minus 8 whole square plus 7 minus 8 whole square. So this will be 14. So that is the covariance value. And now second covariance value is covariance of x1 comma x2. Here one more component, extra component is adding x1, x and y. So instead of y we can understand that this is the y value. So x1, x2. So 4 minus 8 whole into 11 minus 8.5. So the mean of y is 8.5. So that's why we have written 4 minus 8 into 11 minus 8.5. Similarly for the remaining samples, 8 minus 8 into 8 minus 8 into 4 minus 8 minus 8 into 4 minus 11.5. 13 minus 8 into 5 minus 11.5. 7 minus 8 into 14 minus 8.5. So likewise we have to calculate, and I will get it is around 11 minus 11. So for similarly for the third component, third value is x2 x1. It is also same minus 11. So the last value in the covariance matrix is yy are nothing but y2 y2. So for the second one only, so it is around 11 minus 8.5 whole square, 4 minus 8.5 whole square, 5 minus 8.5 whole square. So you will get the fourth value is 23. So now the covariance matrix is 14 minus 11, 11 minus 11, 23. So second step is finished in the algorithm. Third step is calculation of eigenvalues of the covariance matrix. So for this matrix, so we have to calculate the eigenvalues based on this. So we already know how to calculate the eigenvalue. It is around it is determinant of s minus lambda e is equal to 0. So based on this, so we have to calculate the lambda 1 and lambda 2. Two eigenvalues will get. So the equation will be 11 lambda square minus 37 lambda plus 201. So for this we can apply, we know how to calculate the second degree polynomial algebraic equation values. Two factors we have calculated, so we can use the formula minus b plus or minus root of b square minus 4ac by 2a, or else we can directly calculate the factors. So we will get the values like lambda 1 lambda 2 30.38 6.615 like that. So third step is finished. After that we have to calculate the eigenvector. So for calculating the eigenvector, so from these two eigenvalues we have to take the largest eigenvalue. So the eigenvector is u1 u2, so we have to equate it to 0 to calculate the equations or u1 and u2 values. So s minus, so first case is we are taking because of largest value we are considering, so that's why lambda 1 will become 30.8 something. So before substitution, so you'll get two equations. So these are the two equations. After getting these two equations, um, so we have to equate them to t, because to solve the u1 and u2 values, so we can take the t1 as any real number initially. Just assumption we are taking t is equal to 1. So then u1 will be 11. U1 is nothing but 11 and it is 1, so that's why u1 is equal to 11 and u2 is equal to 14 minus lambda 1. So now from this eigenvector, so we have to compute the length of the uh, x1 components. So the length of the u1 is root of 11 square plus 14 minus lambda 1 square. Lambda 1 is already calculated, so from this we will get 19.73. So after calculating this, finally we will get the eigenvector u1 and u2 components. 11 by length and 14 minus 11 lambda 1 by length of the vector. So after calculating this, finally we will get the e1 values like 0.5574 minus 0.8303. e2 similarly, so these are the values. After finishing this fourth step, finally you need to calculate the principal component for every sample. So in the example already we have shown, so for each sample we have to calculate the principal component. So sample 2 principal component, sample 3 principal component, sample 4 principal component. After calculating this, this is called the new derived data set. So that is the intention of the concept of principal component analysis, dimensionality reduction to be done. So for that we have to follow the formula. So the transpose E transpose into x1k minus x1 bar, x2k minus x2 bar. So already we know what is x11 and x2 x1, this is x11, x12, x13, x14, x21, x22, x23, x24. So based on this, first of all we need to calculate the first principal component. So here we are taking e1. So we have two values are there in matrix. So we'll take first one e1 transpose into this is the formula. So we can substitute it and we'll calculate, we'll get this equation. Already we know the values of x11 and x1 bar and x2 bar, and so like that we have to do, and finally we'll get the first principal component is minus 4.305. For remaining we have to calculate, we will get the values like pc2, pc3, pc4. For similar same wise we can calculate for sample 1, sample 2, sample 3, sample 4. So after calculating this you will get these values. So these are the principal components or the final new derived data set. So that's all about the concept.